Okay, in our previous class we studied the image formation by a concave mirror. Now we'll do the image formation by a convex mirror. For this we consider two positions of the object. For the convex mirror we'll consider only the two positions of the object. That means two position of the object for studying the image formation by a convex mirror. First is when the object is at infinity, and the second position is when the object it has finite distance from the mirror. Okay, now here also we'll get the, just look at here, look at this table. That first one we have the position of the object, second position of the image, a third size of the image, and fourth we have nature of the image. Now here for the convex mirror we'll take only the two position. First, if we'll get the object at infinity, where we'll get the position of the image, that is at the focus. Just look at here. First we'll discuss this table, then I'll show you the raw diagram. Okay, now second image का form हुँदो रहेछ infinity मा object राख्यो भने, this is for convex mirror. Okay, at the focus point F behind the mirror, that means mirror को पछाडिपट्टि form हुँदो रहेछ है, not on the mirror, mirror in front मा हैन, behind the mirror. अनि highly diminished point size, highly diminished सानो हुँदो रहेछ. अनि image, nature of the image is virtual and erect, which cannot be obtained on the screen मा form हुँदैन. अनि second के कुन चाहिँ रहेछ, between infinity and the pole P of the mirror, त्यहाँ राख्यो भने चाहिँ where will get the object, image between P and F behind the mirror. P र F को बिचमा पाउँदो रहेछ, त्यो पनि कहाँ हुँदछ, behind the mirror, diminished, that means सानो पाउँदो रहेछ. अनि nature is virtual and erect, that means we have so far studies about the image formations of concave mirror. No, now we'll do the image formations by a convex mirror by using, that is, ray diagram. Ray diagram I'll show you. Just look at here, this A, figure A, the first go at infinity. This is our convex mirror. Your convex mirror हो. A convex mirror मा we discuss all the points, no, F, C, P हरू सबै हामीले डिस्कस गरिसकेको छ. अब यहाँनिर तिमीलाई object at infinity, this AB is the object. Look at here, this AB चाहिँ infinity मा राख्यो भने हामीले image कहाँ पाउँदो रहेछ, at focus. That means mirror को त्यतापट्टि हैन, पिछाडिपट्टि रहेछ, this behind the mirror will get. Mirror को अगाडिपट्टि फर्म भएको थियो हामीले कन्केभ को त, तर कन्वेक्स को behind the mirror in this focus will get the image. Clear? Then अनि image कस्तो हुँदो रहेछ, point size, this point only. Image लामो ठुलो केही हुँदैन तर point size image will get, that means within this focus only will get the image. Clear? And the nature is virtual and erect, not obtained on the screen. Clear? Now अब अर्को हेर, next हेर हामीले सेकेन्ड मा B मा के भन्यो, between infinity and the pole of the mirror. यहाँनिर हेर, this AB is the object. हामीले infinity कहाँ हो, कहाँको बीच र के को बीचमा, यो पोल को बीचमा राख्यो object AB. त्यतिखेर पनि will get image between P and F. यो P र F को बीचमा पाउँछ, तर कस्तो हुँदैछ, behind the mirror, mirror को पिछाडिपट्टि, यो पिछाडी साइडमा फर्म हुँदो रहेछ. अनि कस्तो हुँदैछ, image is diminished, सानो image फर्म हुन्छ. अनि अर्को nature of the image is virtual and erect, which cannot be obtained on the screen. That means for this convex mirror only we'll consider these two positions. Now we'll have the uses of convex mirror. Where we'll use the convex mirror, that will do used as rear view mirror in vehicle because it gives erect image. It also helps the driver to view larger area. That means this convex mirror are used in the rear view mirror in the vehicles we can use. Now we'll do a sign convention for reflection by spherical mirror. That means the sign convention will do, and this is very important, convention for reflection by spherical mirror. While dealing with the reflection of light by spherical mirror, we shall follow a set of sign convention called the new Cartesian sign convention. That means in order to this reflection of light by spherical mirror, we have to follow the sign convention. That is the sign convention we have to follow, and that is called new Cartesian sign convention. What happened in this convention, just look at here. We'll have the two lines, that is perpendicular and the horizontal, and the perpendicular line will have, and this intersection point, just look at here, this intersection point of horizontal and vertical line, vertical and horizontal line, we call the origin, that is represented with O. Clear? That means that for the sign convention, what you have to remember, the object is always placed to the left side of the mirror. That means this sign convention you have to tally with the mirrors. Okay, and for the mirrors you have to remember the object is always placed to the left side of the mirror. Mirror को तिमीले always object चाहिँ left side मा राख्नु पर्ने छ. Okay, number 2, you have to remember all distance should be measured from pole parallel axis to principal, parallel to principal axis. That means you know the principal axis. You have to remember all distance should be measured from pole P parallel to principal axis. We have to remember always we have to measure the distance from the pole. You know the pole. Ani pole tenko parallel to principal axis. Then we have to measure the distance. Okay, number 3, you have to remember take P as origin. That means हामीले mirror लिँदा चाहिँ मैले अघि origin O भनेको थिएँ, intersecting point, no, vertical and the horizontal. But here for the mirror, this origin line we can take P as origin, that is distance measured. Clear? Now another thing what you have to remember, that means just now just look at here, this horizontal and vertical line I've drawn, no, this अब यही चाहिँ तिमीले with the mirror you have to do, just look at here like this. Clear? Mirror मा त यो pole लाई चाहिँ you have to take at origin, and origin बाट pole बाट you draw one line, that is the x axis, and give the name x dash x like this. Clear? अनि this mirror यो ठाडो line mn, this is the vertical line, and this axis is the y axis in the graph, which we did in the previous class also. Clear? Now here next thing what you have to remember, right of the origin, your p को right side चाहिँ always positive हुन्छ, are taken as positive. Right means positive. Left of the origin, your origin को left side is always negative. Left means the negative. And another thing what you have to remember, perpendicular to and above principal axis, your principal axis को माथिल्लो side जहिले पनि माथि up is always positive, taken as positive, and perpendicular to the below principal axis, your principal axis and munipati is always negative, you have to take. Clear? This is our sign convention which you have to remember for the spherical mirror. Now next important we have mirror formula and magnification. What is mirror formula? Now here we have the mirror formula. This is formula we have given 1 by small letter f is equal to 1 by this v, just like v, no, we call this as mu plus 1 by u. Clear? Just look at here, what is this f? This f is distance between f, capital letter F, and pole. The last class also we discussed. And this mu is the distance of image from pole. This v is distance of image from pole. Okay, now this u is the distance of object from pole. This v is distance of image, u is distance of object, and that this is also from the pole. And what is r? R is the distance between center of curvature and pole, capital letter R. In the previous class also we discussed, where small letter f is equal to r, capital letter R by 2. This relationship is also we did, and this is the mirror formula. That means mirror formula is 1 by small letter f is equal to 1 by v plus 1 by u. Clear? Now next is the magnification. What is magnification? It is expressed as the ratio of the height of the image to height of the object. Simple. Magnification ke raisa is the ratio of height of image divided by height of object. Clear? Now Now look at here, small letter m is equal to height of the image divided by height of the object. As in the definitions we said, magnification produced by the spherical mirror gives the relative extent to which the image of an object is magnified with respect to the object size. So we can write down m is equal to height of the image divided by height of the object. Now this we can write down small letter m is equal to h dash divided by h. H dash is the height of the image, h is the height of the object, and give this as equation number 1. Now next, the magnification m is also related to the object distance u and image distance mu, and it can be expressed as magnification small letter m is equal to, we know, h dash divided by h. Now this we can write down in terms of object distance and image distance, so we'll get minus mu by u, and give this as equation number 2. Now from equation 1 and 2, from equation 1 and 2 will get m equals to h dash divided by s equals to minus mu by u, where h dash is image height from principal axis. Now h is object height from principal axis. Now you have to remember, if magnification m is greater than 1, the image form is magnified. M is equals to 1, then image is of same size. M is less than 1, then image is diminished. You have to remember. Now why we have written here minus mu, minus v? Because the image is formed on the left side, so we can represent it with the minus. You may note that the height of the object is taken to be positive, as the object is usually placed above the principal axis. Clear? The height of the object, the height of the image should be taken as positive for virtual image. However, it is to be taken as negative for real image. A negative sign is the value of the magnification indicate that the image is real. Negative means the negative sign of the image means the image is real. Okay, and the positive sign, negative signs and image is real. A positive sign means the image, positive signs of magnification indicates that the image is virtual, that means which cannot be obtained on the screen. Real means which can be obtained on the screen. Magnification को sign we can identify the image, nature of the image. Clear? Now in our next class we will discuss about refractions of light. Okay.